Hello and welcome to the second video of LLM 0200 series. As I said earlier, in this video and the next one, I'm going to cover some of the basic knowledge that we need for designing our chatbots. This video is about text embedding, and at the end of the video, we are also going to implement a simple RAG system. So these are the topics that I'm going to cover in this video. First, I'm going to show you how text embedding can capture the semantic relationships in a piece of text. And then we are also going to see how we can apply and implement, how we can perform a vector search using cosine similarity technique. And eventually, I'm going to go through different steps of a simple RAG system, and we are going to implement it in our notebook. However, I'm going to provide you with two different notebooks. The first notebook is going to use OpenAI models, and the second notebook is going to use open source models from Hugging Face. So you can explore both. For the OpenAI one, you need the OpenAI credentials, but for the second notebook, you can just execute it on your on Colab, on Google Colab, or locally. So let's begin by walking through the code. Before I start, as I said, you already have access to the codes in the repository. So if you go into the repository in the tutorial section, you will see text embedding tutorial. And if you open text embedding notebooks, on one side you can see the OpenAI one, and also you can see the Hugging Face one. So I've already executed the notebook in which we are using Hugging Face models. I'm going to keep it on the side just to see the results and to eventually see how the open source models are doing compared to the OpenAI models. Although our main goal is not going to compare these two models, but we are just going to see how each one of them works and if actually we can use the open source models for our RAG system. So let's see actually how they work. On the first cell, what I'm going to do is just to import some of the key libraries that we need for this notebook. I'm going to import OpenAI, I'm going to use NumPy, Matplotlib, and also I'm going to use PCA model from the scikit-learn, and I'm going to apply PCA on our embeddings in order to reduce the dimension from 1536 and 1024 to a dimension of 3. So why I'm doing it is because I want to plot 2D image and 3D image of our embeddings, so we have a more clear understanding of how embedding works. So that's what we are going to do. Essentially, applying PCA on embeddings is not a thing that we do in our projects. We are going to use the full embedding for our chatbots, but for purpose of just visualizing the performance and visualizing and seeing the performance of the models, this is a good way to do it. So let me load the libraries. In the second cell, I'm just going to load the embedding model from OpenAI. And here, what I'm going to do is just to define a few functions. First, a function that plots the 2D image. It gets two vectors along with the labels. Labels are going to be our sentences, our examples, and it's going to plot the 2D image. And in the second function, we will have getEmbedding, which means we just pass a text to that function, and it's going to provide us with the with that text embedding. And finally, I'm going to have a function that just receives two vectors and performs the cosine similarity between those two vectors, so we can see the score of cosine similarity on those two sentences. So in the next cell, what we are going to do is to define 12 examples. These 12 examples are coming from 4 different domains. The first 3 examples are related to animals. The second group is related to sport. The third group is related to modern society. And the fourth group is about programming. So we are defining these examples just because we want to see how embedding these sentences can actually, as we wanted, can actually preserve the semantic relationship from each group and keep each group separate from the other. So let's see actually how it works. So at the end, I'm just going to keep all the examples in a list so I can pass the list to my embedding model, and what I'm going to get at the end is 12 vectors, and each vector is going to have a dimension of 1536. So that's what we exactly expected. Now it's time to apply PCA. So again, PCA, we are going to use it to reduce the dimension to 3. Now let's apply PCA. Now for each vector, which was 1536, we are going to have a vector with the length of 3. So here first I'm going to plot a 2D image from these 12 examples, and then I'm going to plot a 3D image. So here is the 2D image of our examples. And even without hovering the mouse on those examples, you can actually see 4 different groups here, right? So let's see actually if what we are seeing is actually true, and those groups, like those clusters, belong to the same group in our examples. So if I hover my mouse on these 3, you can see that this is about, these 3 are about programming. So these are very well separated from the other groups. This one is about elephants and falcons and whales. So this is the group about animals. Here we have a group about sport, and here is the group about modern society. So OpenAI did an amazing job on separating those groups, but as you saw, it preserved all the content and all the information within each sentence, and that's why these sentences are falling close to each other, and that's what we are going to leverage when we are doing when we are using this when we are using it in our RAG project. So let's see how actually our open source model does on the same group of sentences. So I'm going to use the same group of sentences, and here is the examples. So I still can see 4 different groups. I still have some questions about these parts. So let's see actually how it did on our examples. So on the right, I have 3 examples about programming, right? And here I have one about falcons. I have one about sport. I have one about a blue whale. Oh, that's interesting. And here I have one about modern society, so social structures is, and social structures is this one. The first one actually is about animals. So we have one about animals here. We have another one for sport and another one for sport. So what we just saw is we have programming group here. The animals are these 3, and the sport is like the group that we had for sport is falling here. So the tricky one is the one about Serena Williams, that is very close to these 2. That's what we didn't expect, but nevertheless, this is how the model is performing. And in a moment, actually, we are going to see that this model is still good if we want to use it in our RAG project. So, I mean, OpenAI clearly had a better performance, but we are not here to compare. We are just here to see the different models, and we are going to see how they are working with our sentences, and eventually we are going to see how good they are to be used in a RAG system. So let's plot the 3D image. My goal for plotting the 3D image is just to show you that if we increase the dimension from 2 to 3, the model, like the image, is going to show us a more clear and a better way of like how those groups fell into different sections of the image. So my point is, as we increase the dimension, we can see that the sentences are going to be separated in a better way, and it's going to be more clear. So this shows that the model with 1536 dimension eventually has a lot of power to keep and preserve the content within a sentence, and to keep the related sentences, those that have a close meaning, together in the same group. So let's also see the 3D image here. As you can see again, the 3D image shows that like by increasing the dimension, we are going to have a more clear clusters, but at the end, this model had one sentence which was actually closer to the 2 sentences about animals, which was something that we didn't expect. So let's move on to the next step. So as I said, we are going to use cosine similarity for a vector search. And what does a vector search mean here? What I'm going to do is just to compare two sentences and to show you how sentences which are coming from the same group are going to get a higher value for a cosine similarity result. So the first group has two examples about animals. Then we have one example about animal and one about programming. Then in the second group, we have two examples about sport. And then we have one about sport and one about programming. So what we expect is to see a higher value for this one compared to this one. And we expect to see a higher value for this one compared to this one. So let's see how that works. The two sentences about animals have a higher value for cosine similarity compared to the example in which we had one sentence about animal and one about programming. The same thing is happening for the second group, but let's also see how the open source model did. So as you can see, it still provides us with valid results. So this is a good model. This is still able to distinguish the concepts and capture the meanings and the semantic relationships in sentences. So you can see that if we apply cosine similarity, the first example has a higher score compared to the second one, and this example has a higher score compared to the fourth one. So far, so good. So the open source models are good, are acceptable. The OpenAI models are a little bit more powerful, but again, I'm not going to compare. I'm just going to show you how different models work. In the next step, what we are going to do is to design a simple RAG system. So from what we just saw in the notebook, now we are able actually to build a very simple RAG system. I'm going to imagine that this is a system and there is a user asking a question and we have a database. So for our database, I'm going to consider this all input text as our database. So the way that RAG systems work is you have a vector database that contains both the vectorized version of your text along with the corresponding text and the human readable text along with it among the top three retrieved content. So let's see how that can work. So first I'm going to get the embedding of my sentence. Then I have a function called search. What this function does is it gets all our sentences, the vectorized version of our sentences that we just created, and it takes the vectorized version of my query and it applies cosine similarity on those two vectors, and we are going to collect the result in a list called scores. So if I execute the code, you can see that this is the list that contains my results. There are 12 values in that list, which means, for example, the first value is the result of the cosine similarity between my question and the first sentence in my database. So here, what I'm going to do is just to retrieve the top three results from my database. So I have the score. Let's see what are the top three sentences that provided me with the highest score. So no surprise. On the highest score belongs to elephants, and actually we can see the value here, 0.89, which is the highest score. The second score is about a blue whale, like the second sentence is about a blue whale, and the third sentence is about falcons. So we can see that the top three sentences are providing us with the highest score when we apply cosine similarity and we check the scores. So let's see how the open source model does here. So again, the highest score goes with the elephant one, like that's exactly what we expected. The second highest score is about a blue whale, and the third highest score is about Python programmers. So this is not something that we expected, but what is important here is the top two sentences are still relevant to what we were looking for, right? As a matter of fact, the first sentence contained exactly what we were looking for. The second sentence is somehow relevant, and the third sentence is totally irrelevant, but it's not important. This is, so in the RAG system, if I just change this value to 2, it's going to retrieve only these 2 values, and we are still able to find the answer to the user's query and to provide it with a precise and with an accurate answer. So if I collect all these 3 content, I wrap them up with the user's query, and I also create a system role. Now I have a perfect input for a large language model, and my large language model is able to check the content, check the user's query, and tell me if the answer exists in that content. So let's see how I'm going to do it. For my system role, I'm saying, as a helpful chatbot, your role is to assist users by analyzing their questions alongside retrieved content. Dispense answers exclusively from the provided content and refrain from incorporating personal knowledge if the answer is absent in the retrieved information. So the model is going to give us the answer if the answer is within the retrieved content, but if the answer is not included in the retrieved content, it's not going to use its own knowledge and to provide us with what it knows. So this is how you can simply design a RAG system. So your language model is going to just be there to see the content, the retrieved content, see the query, and provide you with the exact answer from the content itself. So this is how we are going to use GPT right now. And if I execute the code, you can see that this is how I'm preparing the input for our GPT model. I have the retrieved content, I have all our examples, like the top 3 retrieved content, and I have the user's query. Perfect. So let's see how GPT is providing us with the answer. If I print the answer, you can see that some remarkable characteristics of elephants include their exceptional memory and intelligence, as well as their ability to live in complex social structures. So this is exactly what we had in our first sentence. Elephants are known for their exceptional memory and intelligence, often living in complex social structures. So this is a perfect answer to our query. And what we just did was we designed our simple RAG system, which can take a user's query, it can perform a vector search, it can retrieve the most relevant content, it can pass it to a language model, and the language model is now able to provide us with the answer if the answer exists in the content. These are the key steps in a RAG system. So if we look at our open source models, again, we just saw that in the top 3 retrieved content, the third example was totally irrelevant, but let's see how it works. So I'm going to pass the exact same system role. I'm going to wrap the query, the retrieved content, along with the system role. And what I'm going to do is to load Llama 7 billion and use Llama 7 billion as my large language model. So if I scroll down, you can see how I'm passing my input to Llama. So if you check the class again, you will understand how I'm preparing my input for Llama. You have to use this format for Llama 2.7, like for Llama 2 models, and then here is the result. So if I print out the result, you are going to see that actually Llama 2 did a good job, but it couldn't follow explicitly what we asked the model to do. Here it says, great, based on the retrieved content, here are some remarkable characteristics of elephants. Exceptional memory. As mentioned in the content, elephants are known for their exceptional memory. They have been observed to remember their herd members, their social hierarchies, and even the location of watering holes and food sources. So as you can see, it was able to retrieve, like it was able to find the answer and to provide us with the answer. But the part that is missing is we asked the model not to use its own knowledge, but the model is still using its own knowledge. So this is an issue. But the point is, when you want to design your RAG system, it is better to use models which have at least, which are above 10 billion parameters, and it is above 10 billion parameters that you can see these characteristics of the models that are able to explicitly follow instructions will emerge. So Llama 7 billion is not a good model for a RAG system, but it is still a very decent model for exploring and seeing actually how RAG system works. So you can use Llama 7 billion, you can use the OpenAI embedding, you can use the open source embedding model that we just used in this notebook, this model for a RAG system, and you can still get a decent system, get a decent RAG system from these open source models. So this was it for this tutorial. Before I wrap it up, I have to just mention about an extra sources as I promised in the first video. So my extra resources is Deep Learning AI short courses. If you are interested to learn more about embedding models, about RAG systems, and in general about the topics around large language models, I strongly recommend you to go through their short courses. As a matter of fact, the idea of plotting the 2D and 3D images from a reduced, like from an embedding, from a text embedding with a reduced dimension is coming from Deep Learning AI short courses. I just elaborated on it a bit more and compared an open source model with OpenAI models, so you can have access to both. I hope you enjoyed the video, and I hope now you have a good understanding of the whole system. And in the next video, what I'm going to do is go through function calling, and then we are going to start building our systems.